All right, we are live now. All right, good evening, everybody. I'm presenting, welcome to the Inventors Network, for all you new people here. I'm doing the presentation. This is our first one for the year. And the subject will be on the product development process. So let's do it. All right, a few announcements before I get into it. New board members, which I think are actually all the same board members, but we've added Matt King as the financial advisor. So we got Brian James, who couldn't make it tonight, he's the president. Scott Tarsi, myself, as the vice president. Will Peters, IT and marketing. Brian, in charge of science. I thought you did patents and patent stuff. In charge of science, apparently. Terry Moser, the founding director, advisor, and treasurer. And Matt, like I talked about. Okay. All right, so myself, let's see here. So going back to college, I went to Virginia Tech, and I got my degree in mechanical engineering. A few years later, I got an MBA from East Carolina. I've worked in industry. First, I worked for United Pet Group. If you've never heard of them, if you ever had a pet fish in an aquarium, the Tetra brand is probably the most popular thing. So I did the product design there, a bunch of pond stuff. One of my designs is a skimmer filter that takes the water right off the top of your kind of outdoor pond, the leaves and stuff, and sucks it into a basket. That won best new product in category a couple years back. From there, I moved on to Bosch home appliances. So if you've ever seen a Bosch dishwasher in the last couple of years, I designed pretty much every control panel that they have on those dishwashers. So go into a Lowe's, and the control panel, I had something to do with it. And then I moved to Charlotte, and I started my company, and I'll go into that next. But when I was at Bosch, I recently just had 2 patents granted. Just to give you an idea, I came up with the the idea for these patents. Oh boy, I left there in 2014, probably 2012 to 2014. I had 4 things applied for. 1 was given up, but too many times back and forth with the patent office. 1, I think, is still pending. And then, is it working?
It's fine.
Okay. And then 2 have just been granted. So it's pretty cool to have my name on it. But it's a lot easier to get it when there's a big corporation paying all the bills and you just come up with the idea, do a few sketches, and make a quick prototype. So, definitely helps. All right. Okay, and a little bit more about me. I do a podcast, so anybody that's out into this kind of stuff, okay, so I'm talking about engineering, design, and invention. I think it's really important to be a thought leader in your field. And so for me, I thought, and I love listening to podcasts, and I didn't really find one out there exactly. I found a lot of them about entrepreneurs and people that do their own thing, but not specifically with the engineering side of it. So that's why I started it. I've done 18 episodes. You can get it on the website, CADdesignhelp.com, or just search on iTunes for Engineering Entrepreneur Podcast. And plan on trying to do once a week. Something to get it every week. So if anybody out there on Facebook Live is watching and thinks you're a good host, send me a message. Love to talk to you about it. Trying to do it once a week. Oops. Is that next one? Yeah. Okay. So where you can find me as well? I'm trying to do every social that exists. So Facebook, CADdesignhelp, Twitter, Instagram @CADdesignhelp, Snapchat @CADdesignhelp, and LinkedIn under my name, Scott Tarsi.
Quick question, if
Yeah.
you don't mind. For all of us here, which of these platforms have you found to be the most useful in your space?
I don't really track my ROI in terms of like money on it, but I just think that it helps to be out there doing this. I think Twitter's maybe been the best because when you can use a hashtag with like 3D printing, for example, a lot of people can find that and then you can see what you're doing. But it's really hard to say how many people I've connected with as a result. There's really no way to know that. But I know that in this day and age it's important to do these kind of things. I personally don't find it as a big pain in the butt, so I go ahead and do them. And I like sharing what I do, so for me it's no big deal to do it. All right, so my company here, CADdesignhelp.com, I actually started on the side. My first client came at this group. I was working, one of those, I think I was working at Bosch or another one of those jobs. And I was just like, let's see if I can start something on the side. So I came here, got my first client, and then expanded on, I got a lot of clients online as well, and then I actually recently begun inventing more of my own things, selling them on the internet, and that's kind of just another revenue source for me. But up to 4 employees now. Most people work remotely. One guy's local here. What I found with what I do, it's really not necessary to be in person. With the video and just mailing parts to people, I've been working with people I've never even actually had a phone call with, believe it or not. They'll just send me an email, I want this. We'll just messages back and forth, and they're on their way. Some people would do we'll do live, video chats and stuff. But I've got people from all over the country, Los Angeles, New York, even one guy out of Germany one time. So what we offer CAD design services and prototyping services, and I'll go over kind of where my rates of services fall in this. And also low volume production via 3D printing. A lot of people don't think of 3D printing as a production option, but it really is. When you consider the cost of plastic parts and tooling, it can be quite expensive to, let's say you're only going to need 100 parts, or you don't think you're going to sell 100, it will probably be cheaper to 3D print those 100 than buy an injection molding tool and then make it. Because your molding tool might cost you 10 grand. Now, it'll get your per piece price down cheaper, but you still have that 10 grand upfront payment. So there's a break-even point for tooling. So this is a good option. In fact, there was one of my clients, he's local here, he had a skateboard invention. He wanted 65 of them as like a test run. So I printed 65 parts. And I can give a better price if I'm doing a bunch of parts, because I'm taking the setup cost and I'm amortizing it over a bunch of parts. So it's definitely an option. And then as far as the printers, I got 3 FDM machines, which is what this machine is here. This is an Ultimaker 2 Plus, and 1 SLA. SLA stands for, go back. FDM stands for Fused Deposition Modeling, and I'll explain how all that works with this machine when I get into that point. SLA stands for Stereolithography, and it's a whole different technology. That uses a liquid resin, and it's cured by light. And the difference mainly is that that machine can offer a lot better resolution, but the resin is much more expensive, so your parts will cost a lot more money. So there's reasons to use it and not to use it. Okay, so moving into the presentation, what my talk's going to mostly focus on is I've been doing this now for about 15 months full time, and I've learned quite a bit with inventors. And I think the main problem most inventors have is they don't know where to go once they have their idea. They don't know the next step. So that's what I'm going to really go over today. I'm going to use some examples. So you're going to bring your idea to life. What are the steps to do it? Okay, so the very first thing is you want to have an idea for a solution to a problem. That's the very first thing, or an improvement to something. Okay, so you have this idea. Okay, I've got a great idea here. What's the next thing I can do? Well, the first thing you got to do is you got to get some image for it. I can't read your mind. So if you just tell me it without having any kind of visual, it's going to be really tough for me or anybody to help you out and get it made. And if you can make a prototype on your own, you don't necessarily have to have a 3D printer. You can just use some paper, some cardboard, or something. That's even better, because now I've got an actual thing in my printing. I can machine it out. If it's metal, that's a better way to do it. People do say, oh, you can 3D print metal. Yes, you can. It doesn't really make sense for most parts because it's just so expensive. And then you can also cast or molding, but that's usually more for things where you have higher volume, because it's usually more of an investment. It's more upfront cost. After this, you can use the CAD file and or prototypes at a minimum CAD file to go to a manufacturer for quotes. I have some connections to injection molders, so certainly, and I've done that for clients. I've gotten them hooked up to where they get mass produced. And for that, like at least a CAD file, but normally, before you even get to that point, you want a prototype, because once you make an injection molding tool, it's very expensive to change it. So you want to have your design proven out, know where it's good to go, and then go to that step. Any questions at this point before I continue on? Good, all right. Facebook Live, I can't see you, so we'll have to go with it. All right, so solution. We had the problem there, you don't know where to go. What do we do? Well, I started explaining through that. Oops, I think I duplicated a slide there. Okay, so we're going to go through some examples here to explain this process. So the very first thing is an invention I came up with. I got this cup as a gift. It's great. Everybody knows how hot the summers are here. It's like 100 degrees, right? These cups, there's a bunch of brands, Yeti, Calcutta, I think this is a Calcutta. But they all work the same way. There's a vacuum sealed space in here that keeps it cold. And I love it. But I'm telling you, this is a big problem. whoever designed this made a major flaw where they left a big hole in the lid to drink out of. They didn't use a reclosable. And so when I first got this, I said, oh, this is a really annoying problem. I'm gonna make a solution. So with the 3D printer and some CAD, that's what I did. So, okay, the problem, water splashing out, idea was to plug it. So how did I do that? Well, the first thing is I just measured it. So I've got tools here. This is a pretty basic tool. Let me get it out. This is a caliper, digital caliper. So I just measured this hole. Okay, I'm getting like 8.2 millimeters thick or wide by 27 millimeters long, right? And I also took a picture of it to get the profile. Now I made a CAD file, so I'm going to show you. I'm even going to go into Solidworks, which is the program I use, to show you how I actually did that. So I'll bring my chair around. Switch programs. I got to get out of PowerPoint to do that. Okay, here we go. Okay, so this is the CAD file. It's already built, but what I'll do is I'll just go back. So this is the feature tree, like the steps I used to make it. So I'll just roll back and just kind of go through it, just to show you how I did it. There's a little bit of a lag. So I was talking about the picture of how I did it. And so the very first thing was, let's see if I can show you here. Yeah, thanks. So that's the picture, and I measured it out. And so I started creating, I may have wrote it down there because I didn't want to forget what it was. And I started creating like just kind of the bottom of it. Now what I did was I tapered it because I knew that like when it's, and I have one of the prints over here, but I knew that it had to kind of fit in there and jam at some point. So I put some taper on it, and I kind of used that there. So that's the end result. But so the first step was I kind of just started creating that taper, and then made it longer. So that's kind of like, imagine that's kind of sticking through into the cup now. So I know it's gonna fit at some point along that. And this is a really simple model, but it does solve a problem. And then I just put a little handle on it, and then that's it. So okay, so that's the 3D file, right? So I can see it. You know, I can measure stuff in here. Like if I want to know how wide this is, and that kind of gives me, and just the experience of doing this kind of gives me like, okay, I thought this is going to work, but I don't know. You know, I don't know if it's going to work. It's just in theory. So I'm at that phase, and so the next thing that I do is, well, I actually have to export this file out as what's called an STL. That's what you need for 3D printing. So I hit Save As, and then I hit STL over here. But I've already done all this, so I'm just going to skip that. Now I'm going to show you how I 3D print it, and I'll actually turn on the machine and do that. So I have a program here. This is called a slicer. So if anybody's ever 3D printed, you have to take that. The STL file basically is like a bunch of triangles. It's just breaking the CAD file into that. When you load it in here, this program will generate what's called G-code. That actually is the pass. That tells the printer, move here, put down plastic here, and all these things. And so in this program, here's the part, like I just showed you earlier. And this is my, I think this is probably on my Fusion. I have 2 more printers, or 3 more, and so this is a lot bigger. Like this represents the space inside of here that it can actually print in. So you can see, like, even on this machine, it's that little thing will easily fit. And what I did was I'm selling these online, and like I used to make one at a time, and then I realized, oh, this is really dumb. I'm gonna print 100. So I printed 100, and now I've got a big stockpile available. I'll have to set it up and run it one at a time. But okay, so I've got it on there. It's amazing how many settings you can do in 3D printing. It's like I'm still learning every day all these different things, but you know, you kind of get it set up to where you want. And I'm not going to go into all this right now. This really isn't necessary. But the main thing is you get it set up the way you want, and then you can hit prepare to print, and now it generates the G code. Like I said, you got to hit this save toolpath thing here, but that gives you your file. So I take that file and I'll go ahead and put it on this little SD card here, stick it in the printer, and now I'm ready to print. So you get in the printer here, you gotta have, now when you're in that program, you've got to have it set up for the material, which is what I have in here. There's different types. There's PLA, which is what I made this out of, but there's a bunch of other things, just depending on what materials you want to use. I knew PLA would work fine for this, so that's what I did. So once you get it in the printer, just hit the print button, scroll down here, and I call this the Yeti plug. So that's the file I have up. You gotta have glue, that's important. It won't stick to it, actually. The plastic won't stick. So you put the glue down. So I don't need a ton, because it's just a small piece in the middle. All right, so I got the glue on there. Maybe a little bit more. All right, good enough. Okay, now the first thing it has to do, there's two things. So every material has its own temperatures it needs. This build plate will heat up to 60 Celsius. That helps the plastic stick to it. ABS, for example, has to be much higher. It has to be like 110 because ABS material will want to just warp, and the heat helps hold it down. So that's happening. It's happening slower than I'd like it to. I have to find some. I don't want to jump to the next thing in the presentation until I explain how this works. But I guess while it's heating up, well, it has to heat that up first. I don't want to jump around too much. It also has to heat up the nozzle because the plastic has to melt to put it down. So what's going on here is in the back, I don't want to turn it while it's moving, but you've got a roll of filament. Let's see if I can. Well, if you guys want to step around here, take the camera. It's better just to leave the machine. I don't like moving it while it's moving. But this, again, is called FDM printing. So we were talking about that earlier. They all use these rolls of filament. So FDM stands for Fused Deposition Modeling. So what this is doing is it's going to pull this through here, through this tube. This is called a Bowden tube. There's different, most printers, FDM printers work this way, but some of them will actually not use this tube and they'll pull the material here. But this is the extruder. This is there's like a gear in there. It's gonna push this up through the tube into this nozzle. This nozzle's hot, it melts it down. And then what's gonna happen is it's gonna build it layer by layer. So if we look at some parts here that I've already made, you can see, and I'll pass this around, there's little lines. Well, each of those lines is a layer. So imagine if this model here, at the very first layer, it's just this square, and then the next one's up just that one, and so on. And then over time, it builds the model in 3D. So that's pretty much how it works. Any questions on this part of it? This is going to start eventually. It's at 48C right now.
Is that two pieces or one piece?
This is one solid part here. It ran out of material. That's why it ends like this.
Okay.
It was in the middle of the night, and I thought I had calculated I had enough, but I miscalculated. So let's see. We're at 51. And if you guys want to see some of these other things here, go ahead and pick them up and look at them.
This is just a regular paper glue stick.
Yeah, exactly. Just like school glue.
Yeah. Have
Yeah.
you found that any work better than others? Because we struggle with with the warp. Yeah,
Well, do you have a heated bed?
We do have a heated bed.
You do? Okay.
It's the,
You have to make sure you have the right temperatures for each material.
yeah.
That's important.
Okay, well, we're not trying to.
Which machine do you have?
The U printer.
Okay. It also helps. I haven't ran ABS on this machine, but one of my other machines is a Fusion F400. It's enclosed, so it captures the heat better. While this is doing that, I can bring up their website and show you what it looks like in Fusion. Okay, yeah, so this is my machine here. So this thing's really big. I can't even get it in my car, so I couldn't bring it if I wanted to. I'd have to run a van. I didn't want to go through all that. But it can make really, really big parts. That's why I got it, because there's been plenty of projects I've worked on where The only way I could do it before I got that machine was I had to split it into parts and glue it together, and it's just suboptimal. You know. Okay, here we go. Finally. So it's all heated up. They heated up the bed to 60. The nozzle is going to be around 205 Celsius or so. The first thing it's going to do is just kind of eject some material just to kind of clear it out a little bit. So there it goes. See it start to come out. That's just the purging sequence. All right. And here it goes. All right, so that's the very first layer. Well, that's actually the perimeter layer. So this just kind of puts down an outline. So now it's doing it. So imagine if you had this plug, and the very first section of it is just that thin little thing, and then it'll fill that in, and it'll keep going up. So it's what it's doing right now. It's filling in the bottom layer. In this file, it says time left 20 minutes. So you know, this little small part doesn't take too long.
Have you sold any of those plugs yet?
Oh, hundreds of them.
Really?
Yeah. The number one complaint with this cup, like I'm saying, solve a problem. If you solve your own problem, you're likely to solve other people's problems. The number one complaint with this cup is that it has the hole in it. Like I did a Google search and like Yeti cup reviews, and everyone says, "Oh, it's a great cup," but I hate that freaking hole. I'm like, "Well, plug the hole." So, you know. I'm getting into that. That will be the next part of the presentation. Yeah, and that's what also what I want to get across about invention and design is that it's like a process. You'll come up with the first one, and then you'll find, oh, I can improve this, or I can improve that, and it goes from there. So.
Have you made any case with Yeti at all?
I did try to license it to them, and they did not want to take my phone calls. But I'm in talks with getting it in Dick's right now. I've showed it to them, so we'll see how that goes. Hopefully I'll get it in there. So, as you can see, it's kind of slowly moving up, and it's just making it, you know, eventually it'll be that. So, just filling in there. And that actually, these are not 100% solid. It doesn't need to be. It puts it around the perimeter and then fills up some in the middle. Now, I could make it 100% solid, but it's really just not necessary. It's plenty strong. Yeah, go ahead and pass it around.
Why do you pick the hard material and not TPU?
Well, you can't print in TPU. Well, actually, you can now, but about 6 months ago. The 3D printing world is greatly, right, if you don't mind getting that, where it probably should. But we're going to go into some improvements I made on this thing. All right, so here's where we were. All right, so I was at this point. Here. And, oh, okay, I didn't make a slide on it, but I did make some improvements. So, the very first thing I did was I said, oh, I might lose that little thing. I did lose one of them. I had to make a new one. I said, I'll put a cord on it. So there's the first improvement. It's just a little elastic cord. So I put a little hole in the bottle. That's no problem. To change the model, put a little hole in there. Yep.
Yeah, I was just wondering, did you choose a plastic that's food safe?
This plastic PLA is made out of plants. Now, there's not a ton of research on this stuff because 3D printing is so new. I've been using this thing for 6-8 months, and I have had no health effects. So I'm going to use myself as the guinea pig and say that it is 100% safe. I mean, everything else you're exposed to in the daily life is probably much worse than this little piece of plastic. You know what I mean? If you think, hey, you're pouring your water into a plastic cup, right? It's probably the same plastic as this. You know. So I mean, I wouldn't eat the thing, but yeah. So that was the first improvement. Yeah, somebody said, well, you're gonna lose it. Very valid point. That was the first improvement. Now, the bigger improvement is this new version here. Now, somebody did mention printing a TPU. I have had some TPU samples, and it's really still not super flexy. This here is true flex. This is actually silicone, but you can't print in silicone. So here's the trick: you can 3D print a mold and use the mold to make a silicone part, and that's what I did. So I'll jump back into Solidworks and show you that file. And I like this new version better. That's why I went away on my own cup from the other one, because it actually fits the hole better. Now, both of them will block the water. This thing's not designed to dump it upside down, because there's another hole in the lid, like a tiny little air hole up here anyways. But the whole point of this was to keep it from splashing, and it works fine for that. This works a little bit better. That still works, but this is, let's say that gets 90%, this gets 100%. Yeah, just, I mean, I would drink out of this thing, so maybe don't touch it. Drink out of it for a long time. Probably needs to be go through the dishwasher one time. Yeah, go ahead, Joel.
Also, if that piece without that band, if it was laying around a little kid, you have to choke at it also. But with the band, you don't have that.
Yeah, well, the band, I never even made a version without the band because once I realized that version, how much better it is, I put the band into the model.
Oh, right
to make
away.
it-
Okay,
to
got
make
it.
it, Yeah. So,
It's still a choking hazard, but you've got a remover handle.
Yeah.
and I mean, most young children are not drinking out of these kind of cups. They have their own cups, So what does that look like? Like, how did I do it? Okay. Trying to find it here. Here we go. Okay, so this is the file. So this is the two halves. And so, like I said, just like 3D printing that, I 3D printed these. This is just the CAD model of the plug itself. You don't actually print that. What you do is you print these two halves. I'll just hide this. And when you stick these two things together, that's why it has, if you look at it, it has this little post on one, and then this little here. This is to help line it up. So each side has looks like 6 of them, 6 of those things. And I take these two. I should have brought it with me, but I put it together and I actually clamp it down to keep it from. Because what's going to happen here, and this happens every time, it's just no way to avoid it, is the plastic will actually kind of seep through the edges when these two are together. It just is what it is. I think that if I possibly machined it flat, maybe it would seal better. That's something I want to try. But I can just take a knife and just cut the excess off. They call that flash. It's like just injection molding is the same thing. But what I do is I just put a funnel in up here after I have these clamped together, and then it's just a 2-part silicone. There was a guy who did a presentation here like 6 months ago. It's a company called Reynolds Materials, and it's just, and I think they're 20 minutes away. They're close to my apartment, like 20 minutes south of here. And I just buy this stuff, and you just mix these two up. You pour them in there in 30 minutes. You get that material and that plug that's on my cup. So that's pretty much the summary of that product, and that's where it's at. And I don't really see much more ways to improve it at this point. If I was going to make 1 million of them, and I may do this eventually, is go to an actual injection molding to make this process less time intensive on my end. But I haven't sold so many of them yet that it's really needed. Yeah, go ahead.
Now, how do you inject it right now? With a syringe?
No, you just the gravity. What I found is gravity will just work. When I first did it, I was trying to pour it in. The stuff is so viscous; it flows so slowly. And I was trying to pour it in, like I'd have to sit there with the thing and keep pouring it, and it would slowly fill. Now I just put a funnel up here, dump it in, and gravity will just push it all the way through. Okay. And one important thing to note when you do this, you want air holes here and here for it to vent. Otherwise, it won't come out. So I know when it's full. When I'm done, at this point I've measured how much material I need, but beginning I would make sure that there would be a little bit coming out down here. That way I knew that, because based on gravity, it's going to fill that way, and all the way down, and then it'll come out, and then you'll be good to go. So, more than one ways to make things. Sometimes you 3D print the part, sometimes you 3D print the part to make the part. All right, so next example, and this is a client in Charlotte. The umbrella flask bottle. So this guy does a bunch of Amazon business, and what's really popular is like these little novelty things you can drink out of, especially alcohol. So what he did is he mailed me this bottle, and he's like, I like this, but I want to mix it up. I want to change it around a little bit. So like I was saying earlier, like how you can get started with something, find an existing product and make improvements. He didn't really need to do a sketch. He just gave me this and said, hey, here's what I want to change. So he was okay with this. I think he wanted it a little bit bigger to fit a certain number of shots. He wanted that one, on his page on Amazon, he wanted it like, hey, 25 shots in your bottle, or whatever it was. And he wanted it like an umbrella thing, which kind of is what this looks like. So kind of a lot of copying it. But one of the big changes he wanted, and this was a 3D print as a result. If you look in here, you've got this kind of like insert. It doesn't really fit a shot very well. He wanted it to be like a shot cup and have the volume of it. So I changed it around where those threads are and moved them further up. And this is basically equal to 1 shot. And it kind of looks like a shot cup. So, that's the first thing. So, let's see here, something, yeah. He mailed it to me. So the shot cup, the logo. So I'll pass this around once I finish explaining, but he's got his logo on the side. He wants to brand it, obviously, so that was important. And then he wanted to have something you could hook it on, you know, like, okay, now I can carry around my drinks on my belt. So the hook hinge, so see this one here, it doesn't have even a place to, it has this little cord, but he wanted an actual hook. So he has this part existing already from some other product he already makes. So what I did was I used that to build in the little thing. This just kind of snaps in there. And so those were the changes. So I'll pass that around.
I got a question, Scott.
Yeah.
When you do something like that, does that become your idea or his? Because it seems like
No, I always, when I do stuff for other people, I tell, hey, I'm doing the work for you. You own the like the. I think it's bad. I think any designers out there that do work for somebody and they say, oh, I own the files. No, if the person pays up for everything, then they own everything. So I don't try to claim that I own that, and I'm not in the business. It would be terrible for me and my reputation to start 3D printing those and selling as a competing with them. That'd be stupid. I'd ruin my reputation. So I'm never going to do that. And anybody, and like I said, and I always give the files to people because they paid for it. So, okay, let me go into the CAD of how I made that. I'm not, because I'm already printing that. I'm not going to. That would take too much time as well. So I'm not going to 3D print that. But I think that from the example here, you guys get how that works. All right. Here. Umbrella flask. There we go. Okay. So, yeah, I think this is a little bit taller, the red part here. You can see that his company's shark skin, there's brand. So I put that in. You got a little shark guy there. I didn't put in the model of the actual hinge thing. It really wasn't needed. I just needed to have this in there. And let's see. Okay, I guess I can like this. What's cool with 3D printing too is you can 3D print functional parts like these threads here that I made. Actually, who has the part? I didn't print the whole bottle. See, he just wanted me to print and make sure that it worked, and he kind of wanted to just see this part and make sure that worked. So I just printed. I just cut the model here like that. Got rid of the rest. You know, saved the new file obviously, and then I just made that to make sure that it fit. So you can kind of play with that, and you can see that it kind of screws in. So put that back there with it. So that's pretty much that project. Once I had done the printing, he didn't want to make full-scale parts with that. He already had planned to go to injection molding, and since he's done so many products, he has a company or a factory in China that already does it. So with the 3D CAD file, the company in China can just go ahead and take this and make it mass-produced. But the important thing to get across here is that the 3D printing proved out that everything works, and then you go to mass production. So, any questions on this example? I got one more. I might get through this quicker than I anticipated, but I'm sure people have questions at the end. I have so many things I've done, but I can only talk about stuff that I didn't sign NDAs on or the people that didn't mind sharing. Okay, so I did that. This last one here, it was more of like an art project, but it's still something, you know, so it still has to do with product design and invention. This guy, I think it was inspired, somebody else had already done this, but he wanted to make these kind of cool shapes out of concrete. I think it's gifts or maybe to sell them. And he was thinking about how to do it. I said, well, what you can do, you can see somebody has a mold here, but I think what he wanted to do was make it out of silicone. So it kind of goes back to how I made that plug. What I did was I designed these up. So he had three pretty simple shapes. One like a cube, one kind of like a cylinder, one kind of like this kind of hexagon pattern.
Thanks.
So, you know, I just created files that he kind of told me the sizes, and I kind of went off the pictures. You know, again, like if you give me a visual, it just makes the design process a lot easier. So, you know, I did that for him. That's the kind of hexagon shape. You know, there's just a basic cup cylinder version, and then the square one here. So yeah. So once I had all those, the next step was to 3D print it, because what he's going to do. Here we go. So these are my 3D prints as a result. These were big parts. These took a long time. This one here probably took 25 hours or something. It was really, I mean, 3D printing something that big does take some time. But I sent those to him, and on his end, he's going to buy a lot of silicone. He's going to put these in a big, so imagine a big box, put the part in there, pour silicone all the way around it, so it's rubber, you know, flexible. And then once it cures, he cuts it in half, pulls that out. Now he's got the negative image, and he pours his concrete right in, and now he can just replicate parts. So that's all the examples I have, but I'm sure you guys have questions, so go ahead and throw them at me. Maybe you don't. Yeah.
What's the price point for the large printer that you use?
The large printer, the Fusion that I went over, I think it sells for around 5,000.
Okay.
This machine here retails for about 2,500, 3,000-ish range. Yeah.
Do you ever take a 3D printed part, reorient, and then print it from a different axis? Is that not?
Yeah,
possible?
yeah. We can go over some of the 3D printing, like kind of best practices here. So, okay, here's a part. I'll show this to everybody on the Facebook Live page, if there's anybody actually watching. I think there's people watching. All right, so everyone, this little holder here. Damn, people keep messaging me. I actually 3D printed yesterday before this presentation because I knew I wanted to record it. So that's what's on the screen. So what I'm gonna do is put this back in this holder. Okay. And so what's going on here? With 3D printing, I was going over how it has the lines, how it puts layers down. You can't imagine a shape like this, like a bridge. Like a table even, imagine a table. Like imagine I'm printing this table. This is fine here. It's gonna print this, it's gonna come up, it's gonna come up, it's gonna come up. But all this overhang, even this area over here, there's nothing. So once it gets to this layer, if there's nothing below it, it's just gonna fall down. It's just gonna sag. Because this plastic, it's a thermoplastic. So once it comes out of the nozzle, it starts to cool immediately, but it's not instantaneously. So it's like a noodle, but it's drying or it's hardening over time. So it can go a really short range. Like it can go like that far, but then it starts to sag. So you have to have what's called support material. So if I printed this table, I'd have to have bridges coming up every millimeter, or probably less than that. Coming up. That's a ton of waste. All the support material is waste. It doesn't do any good. It's just there to hold it up. So the best way to print this table would be to flip it all the way upside down, 100%, because then it prints. You wouldn't have to have any support material if I printed this table upside down, because this whole thing, all of this, would be just, there'd be nothing. It wouldn't need any support, and then these could just print all the way up. And a trick here is that actually 3D printing, if I had this, if let's say for some reason I had to have these at an angle, up to 45 degrees I don't need supports. It'll actually rest on itself because it's sticky, and it's also back to the center of gravity. So each of these is imagining these lines, these layers is actually like a cylinder, and you can stack a cylinder on top of a cylinder up till where the center of gravity is over the edge of the part of the previous layer. If I had a whiteboard, I could kind of draw it. But in any case, yes, originally back to your question, the way you orient it is absolutely important, because you will waste a bunch of time and material and probably make the part quality worse if you don't do it the right way. So with this part, this is the best way to do it, because I only need, these red represent the supports. It only needs it here. And that's very, very minimal. That's not a big deal. And then it just prints nicely all the way up. So if I printed this any other direction, if I flip this thing flat, so if I go back out of here, so I can even have it show me what it's going to look like. So let's just take this, and I can rotate it. Where's the rotate? Here we go, down here. Let's just say X. Let's rotate about X90. Okay, so it's sitting flat, and then I just center it again. And then I prepare to print, so it shows me what it does. Well, now look, oh, I have to redo the supports for it. Okay, now it should do it. All right, so now if you look at it, all of that, like gray down in here, has to have support for all of this, and all of this inside in there. And it's really hard when you get supports. The way you remove it is I have this little tool, these pliers here, and you kind of reach in here and you kind of feel it. Well, this is really tough to get to, so this would be a really bad way to do it.
So it calculated the necessary supports for you?
Yeah, the software is great because if you got to figure all that out on your own, good luck. Now there have been some files where I wanted supports out of there because I knew it'd be impossible to get it, and I was okay with accepting a little bit of the part bending or something like that. So you can manually do it, but normally I just give it automatic. But it depends on the part.
Does it give you some basic metrics from those calculations, like amount of fill material in grams or something?
Yeah,
like that?
so this is all the statistics up here. It even tells me how much it's going to cost me to do it. The time is way off though. What they found is that you have to multiply this by 1.5, and that's truly what it takes. And that's been pretty accurate. The machine will even tell you at the beginning how much time left. Like this is only 2 minutes, so you can see it's almost all the way up now. But at the very beginning, when it tells you that, it's way off. You got to give it like half an hour into it for bigger stuff before it's really kind of converging on it. But the initial estimate is 1.5 times that. Yeah. Questions? Comments?
How do you remove the material? Does it take?
Well, as you when this is connected to it, I could print another part if you guys want to stick around with supports in it. But when the main part itself, it's just like it's stuck to it like really solid. But the supports are attached like only at little points, so it's easy to break it up. Relatively easy to break it up. It kind of depends on the shape of it and stuff. But the idea here, and this doesn't do a great job of showing it. What actually happens is it's building. It's just not solid. It has air. It has like remember how I said it can go across a small bridge like. This thing wouldn't be 100% plastic underneath. It would have little spaces. It would be little thin pieces, but almost like a cone, where it have material but then air. And because it's so thin, you can take these pliers and break it. Now, what's cool is that if you have what's called a dual extruder printer, where it has 2 nozzles, you can use a material that will actually melt in water. And my other 3D printer, my oldest one, has it, but my oldest one is very, very slow. The company that made it makes proprietary cartridges. What it means is they're sticking regular plastic in a case that has a microchip on it, and you can't buy anything. It won't work with anything but there. So I don't use that machine very often because they mark up the price of the material so much. But if you have two extruders, you can run the water soluble that melts away in water. So you don't have to manually do it. It's a lot easier. So I still use that old machine for some parts where it's like really tough to get the plastic out.
So it's perforated? Is what is perforated?
Kind of, yeah, that's a good way to think of it. It's like almost like a perforated surface. It's really not perforated, it's just like I said, it's so thin, like, I wish I had some ways to, like, here I got this little purse, like, it's like that thinness wide across. So it's so thin that it's easy to just snap it right off.
Do you find that the 45-degree angle is universally true, or does that vary?
Yes, that's pretty much universally true. But that is the extreme. If you go to that, you still might want to put supports on it.
Okay.
Because that's the borderline. That's the absolute max.
What have you
that you
found
can
to be a safe angle?
Probably 40 degrees would be what I would recommend not going beyond. Because you go beyond that, and it's really starting to hang.
Okay.
It depends on the distance too. If you got like a little short thing, sometimes you don't even have to have it. And it's just kind of a trial and error. 3D printing, I mean, just to make this part here, because now I'm experimenting with different size nozzles. So this, typically most printers will come with a 0.4 millimeter. That's the diameter of it coming out. Mm-hmm. But you can use different types. So this is actually a 0.6, and I'll pass it around again. The lines are bigger, but the advantage is it can make it faster. But what I found out with this was, I see it more quick so I can show everybody. This surface here didn't turn out good because it's stepping up more, and it's a sloped angle, and since it's not stacking right on top, it came out rough. So I decided with this model, I'm gonna go and make it with the 0.4. It's just gonna take more time, but that is what it is. That's why I have more than one machine when I want to dedicate. Because I've had prints literally take 5 straight days. They're very expensive, but sometimes people want it. Like this guy had this huge mask. I guess I can't show it because I think I have an NDA with him. I have to check, but it's a huge mask. It was like a foot tall. It was like the full size of my larger printer. It took 60 or 70 straight hours. So, but I mean that's the advantage of having 2. So I can still run parts other parts on the other machines. And you know, my business plan this year is to get at least one more, probably two more. So.
Do you do more production work or design work?
What do you mean by that?
Well, what you did for me was design work, but you're talking about making parts.
Yeah, yeah.
What do you do more of?
It's kind of 50-50, I guess.
Oh, yeah.
I'm trying to do more of my own things, I just, you know, enjoy that too, but I do a lot of work for other people. But I mean, the only production equipment I have are 3D printers, so it has to be something that makes sense for 3D printing. If it's too high a volume, if it was my own thing, I'd go to injection molding, or somebody else would, because they would you realize the price point would be better. But some things are metal parts for machining and stuff like that. So for my own for production that I do for myself or other people, it's usually through 3D printing, or pretty much exclusively do it. Yeah. But I mean, if you have a part that needs injection molding, I have connection with like 4 or 5 molders around here, because just from being in the industry. Yeah.
What can you do to make all this smooth?
Yeah, so you can't get it 100% smooth. Now this comes back to resolution in the layer lines. There's a couple of factors here. So one is the nozzle itself. How can I explain this? Maybe I can draw, or actually what I'll do is I'll go to one of my blog posts. That would be a good idea. So if you, on my website, there's a ton of information on the website too, if you ever want to read them over. I've written about 50 blog posts.
Can you print color too?
Color?
Yeah, different color.
Yeah, absolutely. I've got 20 different colors. I just have red loaded in here, but normally white and black is most people want.
So you use 2 different extruders, or you use ink?
No, I'll just change the material. Now, yes, you know, I was at CES last week. It's a huge consumer trade show in Vegas, and there was plenty of machines there that have 2, and maybe I'll get one. Like I said, I have that old machine that has 2 extruders, so I could do 2 colors simultaneously. And you could literally change each layer. You could do one layer green, blue, or whatever. You can only do those 2 colors, but you could do that. I haven't seen too many requests for crazy stuff like this, but it can be done. You can also paint it. This stuff is no problem painting. You can spray paint. You can actually make these parts look really, really good. If you put some time in, you can sand it and make it really smooth and then paint it.
Have you ever seen one of those paper sculptures where the Chinese guy, he has some glue and he glues on each sheet and he carves the paper?
I have not, but that's pretty much like 3D printing by hand. That's literally 3D printing by hand.
Yeah.
Layer by layer manufacturing is, you could also call it layer by layer manufacturing. I don't personally want to invest that kind of time in the gluing paper and cutting it, but that's kind of a cool thing. But we were talking about, different colors. Oh, here's something I've done. So you can actually print clear parts too. I wanted to talk quickly about. Oh yeah, this is the project I could show. This is a good chart. Let's see if I can make it bigger. That helps explain the layer lines. Okay, this is perfect. So imagine this is your print. This is the filament itself. So this is like a zoomed in view. Imagine if you looked in really, really close and you cut it in half, like down the middle. Like if I took this part, cut it down the middle, and I zoomed in really close. This is what you would actually see. So this is the rolls stacked on top of each other. So there's 2 things. There's the nozzle diameter, and then there's the layer height. So imagine a 0.4 millimeter nozzle. If you can't set the layer height equal to it, because you'd have just a very small contact point. You actually have to smoosh it together a little bit. So for a 0.4 millimeter nozzle, the maximum. Oh, it's done. There we go. Now we got a red one. Anybody have that cup that needs a plug? I got more than I need. Maybe I'll do a contest. Somebody on their Facebook Live figure something out. Somebody can win that. But the maximum for a 0.4 is generally, for any nozzle, honestly, it's about 75%. So this distance here would actually only be 0.3 because you have to push it into it. The amount you push it in is now the resolution. Like we were looking at this big one here where I used the 0.6. You see the lines more because the situation is like this, but even bigger because it's a 0.6. Now I could smash it down like this situation and make the line smaller, but there's a maximum there too, because if you smash it too much, it'll actually plug up into the thing, and you don't want that, because I did this the other day. You got to pull the thing off and take a blowtorch and melt it. It's just the whole ordeal. So the best resolution will come using the smallest nozzle as much as you can smash it down. So imagine this is a 0.4. I ran parts at 0.1 millimeters layer height, which is about the max, and it's kind of the other side. You can go from about 25% of the nozzle diameter to about 75% as your layer height. But when you smash it down, now the lines become smaller, and it actually becomes a little bit wider. But don't worry so much about that. It's more about this. So that's your resolution, and then you could sand this and actually imagine cutting all these and making it kind of smooth, and then you can paint it and stuff too.
Do you get a stronger part? Obviously, you have more contact.
Yes, you will. That's exactly right. So this is you see, you only got the small contact area. Now you can solve this. This is representing just one, what they call one perimeter layer. So when it goes around the part, like here, when it goes around it, it goes around it, then it goes to the inside more, and you could do that to where it's 100% filled. But what actually happens is, I really wish I had a whiteboard because it's just hard to see on here. But what actually most of the time it does is you don't actually 100% fill it. You would put one layer in, another layer, like 2 or 3 perimeter layers, and then you just use it just does like a hex pattern. So it's just going to put lines down one way. It's building that. It's basically, if you think about it, like internal support for the top of it. So it's fully enclosed. So you don't have to worry about breaking it away. But it looks kind of like that. So that's one outer layer, 2. That's like if you look down on the very first layer, and then it puts this in here. You don't really need 100% fill it. It's plenty strong like that. So this would be only one layer, perimeter layer. But then imagine putting cylinders all here. So it's actually touching. Like if you only did one. You would not want to do this situation if you did only one perimeter layer. It'd be way too weak. But if you put another layer here, then this isn't so bad anymore. And it would be very unusual. You'd have to have an extremely thin part, or you'd have to have a special reason to want to do only one perimeter. So I'm going to show people there, Facebook Live, what that looks like. So you can see how it's kind of a hex pattern like that in the middle, and there's a lot of air and stuff in there. Everybody can see that. That's kind of the idea there. Did I answer that question fully? Actually, what's interesting about what this blog post was about, while I got it up here, is like how well you can see through the part. So the idea what it was with this product is that you could see through this window because there's a light, and it does. But what I found out was that the way that you print it, see how much better that comes through than that? The reason was because this one I printed this way, and this is hollow, so it had to have supports touching all of this. And and the other thing about supports that's bad is when you break it, it's a rough surface. Even if you sand it, it's still never like if it never touched it. So when I printed the second one, I flipped it so that it didn't have to have any supports touching that, because that was the main important surface. And then I found out that the light comes through it a lot better. And then that other image that I was showing kind of explains what's going on with these clear parts, how the light actually refracts. So the less that you smash it, like if I would do this project again, lesson learned I have is that I set mine more up this way. So you can see the light's really scattering through. If you make these, see several internal reflections. Here, there's less. So I first of all would set it up that way. And there's actually this coating. I've used this on other parts for different reasons, but this coating will actually provide, kind of fills in the gaps and it lets the light go straight through it. There's actually a picture somewhere where I borrowed this from that shows it, like that part that I had up being like perfectly clear. But here's the trick to this: is this only works if you have a single layer perimeter or a single perimeter, which is very thin. And the function of the part that I had being this window of this container, that was a design constraint. I couldn't do that. I couldn't make this part that thin because if I did, it would just break. So that kind of idea of making it using that coating and stuff wouldn't have actually probably worked here, but it's kind of a cool thing to see that. So. There's more questions, but if not, then I guess that'll wrap it up for the January presentation.
What if you were to take a heat gun and try to melt it a little bit and you can smooth it out? No.
You'll just get a big mess. Even if you just get it, it'll smear and stuff. Now, there's a cool trick with, and I haven't done it personally, but with the ABS. So this material here was PLA, but with ABS, you can actually put this in acetone. I've watched some YouTube videos of people doing it, and it will actually melt the outer edges. I guess it's probably a chemical reaction. It must be a chemical reaction, but it'll melt the lines together. And you know, there's plenty of people that have done it.
Are they dipping or spraying?
There's a couple ways. I think you can if you put it directly in, it might overdo it. It might wear it away too much. It's better to use like the one guy I saw that did it. He used a vapor bath. So he used just a couple of drops in a jar, closed it off, and then heated it up with something. And the heat made everything, just the whole thing filled with this acetone fog, and that like worked really well on it. But I mean, personally, to me, I think this part looks fine. Like going through all that work for that, like the customer for that part doesn't care that there's some lines on it. I get that some people don't like the lines, but I guess it depends on, at the end of the day, like, you know, what your expectations are. You know, for that, it wouldn't make sense, the time investment to do that on that thing, you know. So.
How long did it take you to print this?
Oh, that little holder, that took maybe 2 hours, 2 or 3 hours. What did you say?
Set it up there for me.
Oh, did oh yeah, but you got to multiply it by 1.5. Remember, because it's not accurate.
We see the piece that you just printed.
Yeah, that's one of those plugs. So where did that put it? Here it is. Oh, you can get it.
So you can program that to just continuously make another one after one was done, or would you have to
No.
actually
So
be in
when you
attendance?
exactly when you set it up, I could do more than one. So I go back in here. It's really easy. I just go back in here, and if I've got the model here. So if I just click up here, well, I have to go click on it. Well, it's already highlighted. So if I can just duplicate it. So let's say this is what I did, because I was making these, like when I sell one, I'd be like, oh, now I got to print another one. I was like, why don't I just print 100? So I could, like, let's just say I just do like 20 at a time. Boom, 20. Now it's obviously sticking off because the program, but it has this nice button here, center and arrange, boom. I've got 20, well, it's like 19 for some reason. But yeah, and then it would just print it, and actually, it won't print one at a time, it'll print each layer at a time, because that's the important thing. You don't want it going up and down and running into it. So if it prints the first layer of all 20, then it can't run into it. So that's an important thing. And yeah, so you can make, as long as it fits inside of the square, then you're good. Inside of the cube, really, because you don't want to go too tall. Then you're good to go. You know.
How did you get this piece to mold to this piece?
So I know a guy that works here, and I texted him yesterday, and I said, you guys got a tripod mount? Because I didn't have one for my phone. And he said, yeah. I was like, do you know what, by any chance, I didn't think he would know. I said, do you know what screw size it is at the bottom? He said 1/4-20. So I just went on Google. I looked up the specs of a 1/4-20 thread. And what's cool is that the 3D printer can print functional threads too. So let me find that file. What was it underneath? I can show you. It puts the threads right in there, and then it's screwed right on. Let's see here. Here we go. So here's that 3D file of that thing. Oops. And then if I zoom in here, you can see there's threads in there. Yeah, and so it screws right on. You know, interesting thing about this is that one of the important things, we're talking about support material, I made sure that I only put like just a little bit in here, because if it overfills this, good luck getting it out. It's one of those lessons learned I did at the beginning. I printed something and it was like impossible to get out of this little hole. But see, this area here, actually, this may even come out without any support, because we're talking about the bridge again, about how much overhang. This is really small, so it might have been fine even without it, but I put a couple really, really small ones in there. You can actually pick what size the supports are. So if I go into here, this is the manual supports. This is kind of like if you're getting more advanced. That's what this support resolution is. I had to pick like 1 millimeter, because this is a pretty small hole. So it's just putting like a 1 millimeter post, essentially. If I pick 2, it'd be a 2 millimeter post going up, and so on.
Do you use the same software for all your 3D printers?
Yeah. So luckily, this was the first one that I had that came with the Fusion, and when I got the Ultimaker, almost everybody uses a program called Cura. So this one's actually a paid one, but I got it included with my printer, the license for it. But I already learned how this one works. They all kind of work the same, but the buttons are in different spots, and so it'd be easier for me to use one. So luckily with this, I can. It's called the slicer. So the file the program that sets up the file for the printer is called the slicer. Luckily, this will work on the Ultimaker as well. So all I've got to do is go up here and hit like a count and then change the version. And like here, I can even show it to you. So right now, see, this is the smaller print bed. If I switch up here, let's say I want to make this on here it is configuration. If I want to make this on my Fusion, I just hit that and then I pick it. I mean, they've got lots of supported. Like, look at all the printers on here. There's hundreds of them. But mine, where's that? Fusion 3, F400. There we go. Boom. That's pretty cool. Huh? It just grows because that's how much bigger it is. Yeah, this thing's massive. I've never printed anything that took up the mask took up the whole height, but it was only like a half moon shape, like in the center. That was only like that wide. So on their website, I think I showed you guys earlier, they printed that entire box, which is just mind-boggling. Where was that at? Yeah, they printed that entire box. That's just crazy to me. I think they just did it to show, like, hey, it can be done. You'd actually have to have, normally you buy these rolls. This roll back here, this is 1 kilogram. I think they probably had to have a 5. That's the biggest that will fit on there is a 5, I think. Sometimes if you printed something, because it's possible that even the 5 wouldn't fill that up if you made it 100% dense, if you just wanted this massive solid block of plastic, that you'd actually have to change it in the middle of it. What you can do is you can, when on your last bit, but you got to be there. You can't like walk away. Like normally these machines run themselves, so you could just turn it on, and when it's done, it just comes down and it's just there, right? So I don't have to sit there and watch it. But if you ran out, you'd have to be there ready to load the next one right behind it, because I think the future, like whoever figures it out is going to be a millionaire, because if you can figure out a way for the machine to know when it runs out or if something goes wrong, it'd be awesome. Because I had so many prints where something happens and it gets stuck in here. This doesn't know. Like the program just keeps having the head move around, but the material's not even coming out, so it's just moving around in air. Or sometimes it actually, I've had so many things go wrong, I can't even tell you. I've had something jam up and then the plastic wraps around this entire hot end, and this is just destroyed. You have to throw it away and get a new one. And if you're under warranty, it's not so bad, but if you're not, then it's like $100 or more to buy that. And so, yeah, if somebody could figure out a way that the machine would know, like it's out of plastic, something's not right, and it's jammed, and it would just shut off, that would be really nice.
Maybe that's your next project.
I'm not in the business of making 3D printers. There's so many people out there, and that's not really what I want to do. I'll let those guys handle that issue, but that's the thing. If somebody can figure that out, I'm going to buy that machine, because that's one, and I could probably figure out doing a webcam. I think that's what I want, because just to at least keep an eye on it when I'm not there.
Mm-hmm.
But you still, imagine something is wrong and you're 30 minutes away. You'd have to leave whatever you're doing and drive back, and you're still going to lose 30 minutes of material, whatever's going on. Like a remote stop would be good. I think people are working on that. Yeah.
Well, going back to those threads, couldn't you just use like a tap?
Oh yeah, absolutely. But why would I do that when I can just put it in the model and not do any extra work? Yeah. But yeah, absolutely. I mean, it's not hard to machine this plastic. It's just like injection molded parts, you know. These aren't quite as strong as injection molded parts. There's a cool company I saw out in Vegas that claims to have improved it. This guy's Ascension. I just bought a roll of their material to test out. But they have this like some kind of coating on it or something. And so where these parts are the weakest, the best part to show would actually be the one that it's on. Where these parts are the weakest is right here. So like, imagine if I was going to try to break this. The easiest way would be the up and down direction, or like twisting about it, because where the layers are bonded together like that is the weakest. Like if I pulled it like this way, I'll never break it, because that's along the filament. But where the filament comes together is a lot weaker. So so they've claimed to figure out a way to have these layers bond stronger together using, I think, some kind of fiber or something. Let's see if I can find it. But I'm gonna try that out and we'll see. But that's the real weakness in 3D printing. I think this is called the fuse filament. Yeah. So see what they talk about here. Through our novel plastic welding process, I think it's some kind of secondary thing, but they say you can join all adjacent filament traces together and you print, virtually landing the Z-strength penalties. Yeah, so the Z-strength going that way. That is the way that the part would fail, most likely.
Facebook Live have any questions?
I don't know. This is the first time I've done it, so let's see if I can figure out how they ask questions on there. I think there's a way. Let's see here. Congratulations, this is your most commented video yet. I don't want to click on something and screw it up. Let's see. Okay, I see. I can scroll back. It shows you when people are joining.
I tried to join it here, couldn't get on.
Oh, you might have to be friends with me to do it. Okay, well, a lot of people joined, but it doesn't look like anybody asked a question. But, yeah. I mean, I can stop it now, I guess. Is everybody... All right. Going off air. See you later.